Welcome to the PVBytes. PVBytes is design, validation, and simulation software for solar photovoltaic systems. It's developed by Invesis Engineering. It comes up with a couple of menus: project, library, utility, licensing, and help. Let's go each of these menus one by one and understand the basics of this software. In library, we have a couple of items. The first item is user location. If you click, you get a window open before you. Here is a Google map. Navigate through the Google map to reach your site. Let's go to the Houston. Hello, Houston. Satellite map. Find out your location. Let's go one of the residential area. This one. Okay. Now, once you have selected the user site or your location, the next tab is horizontal profile, which is basically the sun path chart. Once you click any of the location on Google Map, the horizontal profile or the sun path chart is immediately updated. The next tab is Meteo tab. Over here, you can download solar irradiance data or the hourly data for the whole year, which is basically required for the simulation. We have two sources here, PVBytes from European Commission and the second one is NREL from US. Select one of these. Let's select NREL database, download. In a few seconds, you will get a list of the databases which are available at NREL for this location. So we have a couple of databases, but let's select first full disk year 2022, click OK, and in a few seconds it will download the irradiance data or TMY data for the whole year for this location. Okay, data successfully downloaded from the selected solar data resource. Okay, very good. Now the next tab is Meteo chart. Now the data downloaded here is being shown in average values for each month. For example, the global horizontal irradiance, horizontal diffuse irradiance, and daytime temperature, wind velocity, as well as the relative humidity. So for each of the month, the average values are shown. You can click to see the maximum values as well. In the next tab, all these values are shown in the graphical chart. Now the next tab is roof data. What is roof data? If location is a pitched roof, clicking this button, download roof data, will try to detect various segments of the roof having different pitch and azimuths, along with other data such as total area, yearly, maximum sunshine. This is a very handy tool. In case of location located in United States, Americas, or Europe, most of the rooftops in the residential area or some of the buildings are pitched, they are not flats, and you need pitch or angles of those rooftops to be used in the simulation. So let's click this for this location, and here we go. We get different pitch roofs listed here with the latitude and longitude, pitch angles, their azimuth angles, total area, and as well as sunshine hours yearly for each of these segments. So a designer can pick up the pitch angles for each of the roof and use in the simulation or the PV configuration we will see in just few seconds, and that shall be very handy. You doesn't need to go that side and measure the pitch angles of the rooftops where the solar PV modules are to be installed. Okay, so we have got the complete data for this user site, and we can save this in a file. Just click save and just give a name, Houston. So we already have a one. Let's call it 2 and save it. This can be opened later during simulation or if you are working on the user locations. Okay, next item under the menu library, we have user load. Click, a window opens where you can enter the load profile for this particular residence or the building you are working on. Let's open a saved profile if we have sample. So here we have already saved a user load profile for a particular location. So under the appliances, you can select one of the appliance, enter how many quantities of the bulbs are used, what's the power rating, and here you can enter the load hours. For this particular load, which is bulb, you can specify the specific hours during the 24 hours that how bulb is used or is powered on. So in this case, our 5, 6, 7 and 18, 19, 20, 21 are switched on, which means during these hours, this load is being used. Similarly, other appliances can be configured and we get the load profile for this month, the first month. Now, so here is an option, paste current month data to the target month. Let's select the target month, February, and click this button. So all of the January data will be copied to the month of the February. In other cases, if you want that this data should be copied to all of the months of a year, you can click this button. Another option available over here is this select button, select individual hours or total hours. For example, if you are not interested in giving the overly specific data for each appliance, you can simply give total hours out of the 24 hours how this appliance is being used. So giving 3 hours or 2 hours means, or 4 hours means that out of 24 hours, this appliance or the bulb is being used only for 4 hours. Software uses its internal algorithms to transfer these hours into daytime and the nighttime hours and distribute these hours because it is necessary to simulate per hourly basis for each hour and for each month. This is not a recommended way. The best way is to select this option and give each appliance the specific hours where it is being used. Once you complete all the data, the total energy units or the energy profile here is giving 10246 kilowatt hours or energy units for the whole year. This can also be saved. Just click to save and save it as a separate file. Third item under the menu library is PV module. Click to open the PV module library. Here, this drop-down item gives you a list of the pre-built PV modules available as part of the installation PVBytes. If you select, the PV module is selected, and here are a couple of parameters you can see already filled in. This particular module is bifacial, having the parameters already given. Nominal power is 535 and maximum voltage is 1500 volts. In case you do not have or you can't find out a PV module in this list, simply you can save as new after you fill in all the parameters. Suppose give a name ABCD and give the new parameters all over here and save as new. Here you go. The module ABCD is available here now. This item gives the types of the PV modules you can select, give the name of the manufacturer over here, and this section over here you can filter the PV modules. Let's say if you want to filter out Longi PV modules, apply, and only Longi PV modules will appear in this list. If you like to delete a particular record like this one, delete record. How this data shall be transferred to the project? We will see in the project screen. This window will open up and a button shall appear over here, transfer the data to the project. We will see later in that section. Under the menu library, similar to the PV module, we have inverter and battery libraries. You can open inverter libraries. It comes up with the window showing a pre-built library for the inverters. The type of the inverter is given over here, on-grid with battery or energy storage. And the third item is microinverter. So the above two first items are the string inverters. Select any of these inverters, work on this, or feed in your new inverter if it is not found in this drop-down list. Save as new, similar to the PV module, and use it in the project. Welcome back to the PVBytes. Menu project is the heart of the software. You have two options, new or open. Here is the project screen of the software. This project screen is the system input, and the lower half is the system output summary, while this section is the simulation run section, and this section is to save or open the existing project section. There are a couple of buttons and parameters which need to be fed in before simulation and run. Our most important is project scale. This software has been designed in a way that it caters different scale of the project with different configurations. The first one is the residential building having string inverters. Second option is large scale string inverters. The third option is for the micro inverters, mostly installed on the residential or buildings. Important to select because it has directly PV strings and inverter configuration. We change the option over here, where we give in the PV strings and inverter scheme will change. Before we get into the details of this PV strings and inverter configuration, which has direct correlation with the project scale, let's see what are other parameters. Here we can see project design option. It has two options, auto design and user design and validation. In most of the cases, you may like to have user design and validation, where you will give all the inputs, required parameters in the PV strings and inverter configuration and simulate your design. In the results, you can find out how your conductor and disconnect sizes are in the design. The software will validate your sizes. That's why it's called validation. In other option, auto design, you may like to give minimum parameters in PV strings and inverter configuration schemes, and the software will try to come up with a solution which suits your load requirements over here. We have already seen how to give the user load requirements in the library. Before we select few options from the project scale and project design option, and we give in our PV strings and inverter configuration scheme, let's select other parameters. One of the important is system type. You may have three types of systems over here. First is on-grid, which is simply consisting of PV system connected to the grid. The second one is the PV system connected to the grid, but there is also energy storage or battery system. And the third one is the off-grid, where the grid is not available. So for the time being, let's keep selected this option, that is on-grid. Another button over here is PV tilt and azimuth angles. This drop-down has 4 items. The first one is user selected tilt and azimuth. Second one is yearly optimized, then summer optimized, and then winter optimized. If you select user selected tilt and azimuth, you have to give in PV tilt and azimuth angles in the PV string scheme. If you select yearly optimized or summer or winter optimized, software will itself select PV tilt and azimuth angles according to the latitude and longitude. So you do not need to give in the PV tilt and azimuth angles, and those angles for the yearly, summer or winter optimized options will be selected to optimize the performance of the PV modules according to the season. Next button is user site. It's the user location basically, which we have already discussed in the library. Let's click this, and the same window will open. We found it in the library. As we saved our location, let's open that one. We saved this Houston NREL_2 while we were looking in the library. Let's select this, open. And now we have got this button, transfer data to the project. We already have all the data. We saved it before, and now we will transfer this data to the project. Click. User location data transfer to the project. Okay. Once the project has received the user location data, it shows up green color. Now the next button, PV strings and inverter configuration. Before we get into that, let's select our PV module and inverter. Click on PV module. Our library has opened up. Let's select this, a generic module of 100 watt, and let's transfer this to the project. Click. Okay, so it shows up green. Similarly, we will select the inverter, click. Now the inverter library window opens up. Here, let's select this generic inverter which is on grid, basically a string inverter. All the parameters are already feed in. Let's transfer this to the project. Click inverter module data transfer to the project. Okay, so we have got now PV module and inverter. Now let's move towards the one of the important parameters, input parameters, PV strings and inverter configuration. Click. Okay, so here is the window. In case we have residential building or string inverter option selected in the project scale, this window will show up. For the time being, let's close it. Just want to show it how it gets different when we select different project scale. Cancel. Let's select the large scale and now click. So the PV input and inverter configuration scheme, the window has changed. We will see later how it's different from the other one. Cancel. And if we select here the project scale, the last option, the microinverter one, and click this one, then we have a totally different scheme because in the case of microinverter, the scheme of PV string and inverter is different. So first of all, let's get back to our original option of residential building and string inverter. Click and let's give our parameters over here. This window called PV system configuration, in case of option of project scale as residential building and string inverter, this window is divided into three main sections, 1, 2 and 3. These sections basically represents arrays. Now you can configure array 1 independently of array 2 and similarly array 3. In array 1, you have to specify how many inverters are there. If I select 1 or 2 inverters, this means each inverter will have the same configuration. For the time being, let's select one inverter for this array, and these text boxes represents basically the MPPT inputs for this inverter. There are maximum number of 6 MPPT options which can be configured, but here only 2 are enabled because this inverter has only 2 MPPTs configured in its specifications which we had in the library. So we can use only 2 MPPT inputs. We can configure, or we can say that there are only 2 at the most available for this inverter. For the time being, let's select only one, enable. We have to make a checkbox here that we are configuring the 1 MPPT input for this inverter, and let's start giving the input parameters. Now each row has been divided into a couple of sections. The first one is related to PV module tilt and azimuth angles. The second one called string or source circuit, then the grounding conductor size, how many strings are there connected in parallel, what is the total area of the strings. You do not need to give any input over here. I come later towards the purpose of this text box, and then the combined output circuit. Let me explain this with a schematic. Click tips and a window is showing over here these different schemes. Let me first show you over here PV config 2. This is the typical scheme, or could be one of the typical schemes. There is 1 MPPT input for this inverter, and the 2 strings are connected in parallel to this one. For this string, from this point to this point, this is called string source circuit. And from this point to this point, this is called combined or output circuit. So in case there are 2 strings in parallel, we shall give the number of strings as 2 over here. In this case, the output circuit will be different from the source circuit. So the output circuit we have to give different parameters. For the source circuit, we assume that the both strings in parallel shall have the same parameters over here. Let's see the scheme where only one string is connected. Okay, here only one string is connected, so we are using the source circuit and we will not be using the combined or output circuits and leave it at 0, 0 in the parameters or the text boxes. Let's get back to our original PV configuration window. Now PV tilt and azimuth, let's give some parameters over here. Let's say 30, azimuth 180, facing south. Let's have modules per string, 20 modules, and the DC cable or the DC conductor size, let's say it is 14 AWG, and the disconnect size is 25. Let me show it again. This one, the size of this conductor we have given 14 and the disconnect size as the 25. Okay, and we have to specify how long this cable would be there. Let's say 10 meters. Okay, now we should specify the grounding conductor size. Let's say it is 14, or let's say it's 12, and number of string is 1, which means we are not having the parallel strings, and that means we are using this scheme, and we have two inverters over here. So I will make it 2 just to make it similar, 2 inverters, and total area, let's keep it 0 for the time being. And combined output circuit, as it is not there are no parallel strings, so our string source circuit is same basically as the combined output circuit because there is only one string connected to the MPPT. Now the combined output circuit is all 0. We have given the source circuit parameters, grounding conductor size, number of strings, PV tilt and azimuth angles, and our input parameters are complete for this PV configuration scheme. Let's close this. Yes. Okay, now we have already set the project scale, project design option, system type, PV tilt and azimuth angles options. We have selected user side. We have configured the PV strings inverter and configuration. We do have the PV module, we do have the inverter, and what's left now? Okay, the important parameter or the important configuration is the user load profile. Let's configure this. Click to configure. Okay, the user load profile window will open, which we discussed in the library section. Let's open one of our saved profiles. Okay, here we go. So we already have a user load profile, a typical profile for a residence, and let's transfer this to the project. Remember, we have energy units 10352, annual energy units or kilowatt hours. Transfer to the project. User load has a transfer to the project. Okay. Now it shows up green. So we are now set up for the simulation and run. Before we start simulation, let's see what's over here, PV mounting. In PV mounting, we have a couple of parameters which we can give in. For instance, what's the PV orientation? Is it portrait or landscape? The tracker option is not yet enabled in this version. PV installation, surface type. What's the type of the rooftop? Is it pitched roof or is it flat roof or is it ground mounted? Let's select it's a flat roof. PV modules standoff height from the surface. What's the standoff height from the surface? Let's say at this moment it is more than 3.5 inches. System height from the ground level. There are two options only, 1 story or less than or equal. So we will select the first option, that the system height from the ground level is less than the 1 story. Okay, and bifacial module clearance height from ground is 0 meters, but this will not be used in this case because the PV module we selected didn't have the bifacial option. Okay, so let's close this. Yes, and here we have the type of the conductors we shall be using in this project. Click type of the DC conductors you want. There is a list of the conductor types in accordance with the NEC. You can select any of these. Let's select the most, let's select this one, HHW-2 copper crosslink polyethylene high heat resistance conductor, which is compatible to 90 degrees. Okay, so in AC conductors at this moment we are not using the AC circuit. We have not explored the inverter output AC circuit. Later on we will see that. The grounding conductor, we can use the same one or even some other one. Okay, so here we have to give the conductor height, whether it is higher than 7 by 8 inches, as there is a rule in NEC we have to specify for final calculations. And then the copper conductor, whether it is uncoated or coated. After we select this, let's close this. Okay, and we are all set for the simulation. The only parameters left over are two, which are project preferences, and inverter output AC circuit. In this video, we are not discussing inverter output AC circuit. And about project preferences, let's just have an overview. We have a general tab. What's the nominal grid AC voltage? Number of years to run simulation. 1 year, let's say 3 years. User electrical load, annual increase. How much there will be annual increase in the user load to simulate. Let's say it's 10%. Critical load in percentage of total load. Let's say it's 20%. Enable grid interconnection limit. No. Enable user max ambient temperature. No. In the battery tab, as we are not using the battery in this project, let's skip this one at this moment. Project losses is one of the important parameters we must give in to accommodate the project losses. For the time being, let's assume all losses are 0. Let's close this, and before we close, the final tab is the project report. These are the descriptions which become part of the final project report, and you can type and modify this as required. Let's close this and let's start the simulation. Here we will click Run to start simulation. Click. So now the simulation is in progress. You can see the progress bar moving forward. Okay, just run execution success. The simulation is completed, and now we can see our results here. If we click on the PV configuration button, this will open up the same window we have earlier when we gave in our input parameters. But this time, this will show up with something else. And what is that? The values shaded with red color are not correct. In case of cable or disconnect sizes, it should be increased, and in case of other parameters, try increasing or reducing number. Now here, the software tried to validate the conductor and disconnect sizes in accordance with the NEC and found it correct. Therefore, they are not marked red. But the modules per string is marked red, which means this is probably getting higher in number. So we can try reducing this modules per string to further optimize the solution. Okay, cancel this, and we already have the final results over here. System rated power, monthly energy is this, the annual energy yield is this. This one is giving the energy yield daily, the energy units per kilowatt peak, daily average solar irradiance, which is basically PCH, and system capacity factor comes out to be only 8%. And the reason was that we have selected too many PV modules, as we have also found out that the maximum optimum PV modules which should be connected over here should be 7 and minimum should be 4. Okay, so let's try it again. PV modules in string as quantity, PV modules only 7 in number in the string. But this must be remembered that this quantity is fine. For average number of PV modules in a string should be 7 as a maximum value and 4 as a minimum value are just approximate calculations. It doesn't mean you can't connect more than 7 or you can't connect less than 4. Important thing is that it will not be optimum solution, and the clipping of the power will take place because the more the PV modules are connected in a string, their voltage will go up and the inverter won't be able to handle this voltage. So let's go back to our PV strings and inverter configuration. Let's say it is only 7 PV modules in a string. Okay, close this and let's run the simulation again. The progress bar is heading towards final mark. Run execution success. Now you can see that the energy yield daily has improved to 4.7 and the system capacity factor has also improved. The reason is now the clipping of the power is not taking place now. And now our annual energy yield for this is 2428 kilowatt hours. Let's check the PV configuration again. Now we don't have the red mark here. The system has checked all is correct. Now everything is fine. And now see this text box, the total area strings. We gave 0 input while we were giving the inputs, but now the software has calculated the total area taken by these 7 number of PV modules as approximately 5 meters square. Okay, so cancel it, and moreover we can check the charts also. Click over here This is the system yield yearly, system yield monthly. You can also check year-wise, and load consumption over here, and some other like system to load, system to grid. There will be no system to battery as there is no battery. And over here, daily energy yield chart and plane of array solar irradiance or PCH chart. You can also export as CSV all this data and will come as handy for your internal working or calculations. You can also print a report. Click. Let's open the PDF. Okay, so here's the report. Report by the software PVBytes version 1.0 project report. Client, we did not give the name client. Here is the table of contents, project summary, process details. There is a charts also over here, and PV string configuration scheme is shown in the table over here, as well as the schematic, most important thing.